Welcome friends, this is Atanu Chaudhary of SureSolve. In this first part, we'll now solve the first 5 questions of SSC CGL solution set 58 on Algebra 14 from suresolve.com. A few of the problems may seem to be difficult, but we'll see how to solve them quickly in a few steps. Let's solve the first problem. Question 1 is, if x equal to 5 minus root 21, then the value of root x divided by root 32 minus 2x minus root 21 is option A 1 by root 2 times root 3 minus root 7, option B 1 by root 2 times root 7 plus root 3, option C 1 by root 2 times root 7 minus root 3, and option D 1 by root 2 times 7 minus root 3. Root x equal to root 5 minus root 21 is a double square root surd as root 21 comes under a second square root. To solve the problem, we have to express x as a whole square expression to free root x of its outer square root. This is called double square root surd simplification. Let's do it first. If you consider a general expansion of a perfect square a square plus 2b plus b square, you would notice that the middle term invariably comes with a coefficient of 2. In our case, 5 minus root 21 is the final squared result, but the middle term of surd is without its coefficient of 2. In this case, we use the technique of forcibly introducing the coefficient of 2 by multiplying and dividing the expression by 2, getting 5 minus root 21 equal to 1 by 2 times 10 minus 2 root 21. Now root 21 is to be split into 2 factors in such a way that the sum of their squares is 10. It is easy to see that root 7 and root 3 are these 2 factors of root 21. So we'll express root x in a new way now as root x equal to root over 1 by 2 times root 7 whole square minus 2 times root 7 times root 3 plus root 3 whole square equal to root over 1 by 2 times root 7 minus root 3 whole square equal to 1 by root 2 times root 7 minus root 3. We have freed up the value of root x of its outer square root. Now the value is a normal surd expression. But we won't substitute this value of root x in the direct expression straight away. We will simplify the direct expression as far as possible first. To simplify the direct expression, we would take up the denominator first and substitute the given value of x. We would get the denominator, say d, as d equal to root over 32 minus 2x minus root 21 equal to root over 32 minus 2 times 5 minus root 21 minus root 21 equal to root over 22 plus 2 root 21 minus root 21. The first term is again a double square root surd, but this time the surd middle term has its coefficient of 2. It is easy to identify 22 as the sum of squares of root 21 and 1, and so we express the simplified denominator as d equal to root over root 21 plus 1 whole square minus root 21 equal to 1. The value of the direct expression is then e equal to root over x equal to 1 by root 2 times root 7 minus root 3. Answer is option C, 1 by root 2 times root 7 minus root 3. It's not difficult to solve this problem in mind if you know the concepts and methods. Let's solve the next problem. Question 2 is, if a plus b plus c plus d equal to 4, then find the value of 1 by 1 minus a times 1 minus b times 1 minus c plus 1 by 1 minus b times 1 minus c times 1 minus d plus 1 by 1 minus c times 1 minus d times 1 minus a plus 1 by 1 minus d times 1 minus a times 1 minus b is option A 1, option B 4, option C 5 and option D 0. The main question is how to use the given expression to get a useful relation between the 4 factors 1 minus a, 1 minus b, 1 minus c and 1 minus d which make up the direct expression. It takes just a moment to identify easily that the key lies in the numeric term 4 on the RHS of the given expression. Just share 4 equally between the 4 variables and you will get 1 minus a plus 1 minus b plus 1 minus c plus 1 minus d equal to 0. This is the key pattern discovery for solving the problem immediately. Just add the 4 algebraic fraction terms like in normal fraction addition and you will have the sum of the 4 factors in the numerator with their product in the denominator. E equal to 1 minus a plus 1 minus b plus 1 minus c plus 1 minus d divided by 1 minus a times 1 minus b times 1 minus c times 1 minus d equal to 0. As the sum of the factors in the numerator is 0. Solve easily in mind. Answer is option D, 0. Let's solve the third problem. Question 3 is, if a times 2 plus root 3 equal to b times 2 minus root 3 equal to 1, then the positive value of 1 by a square plus 1 plus 1 by b square plus 1 is option A 1, option B 4, option C 9 and option D minus 5. We identify that the two such expressions are suitable for inversion and rationalization as 2 plus root 3 equal to 1 by 2 minus root 3 and vice versa. We have multiplied and divided 2 plus root 3 by 2 minus root 3. Interestingly, you will get this result for any two terms or expression for which the difference of squares of the two terms is 1. In this case also, 2 square minus root 3 whole square equal to 1. With this result it follows 2 plus root 3 plus 1 by 2 plus root 3 equal to 2 minus root 3 plus 1 by 2 minus root 3 equal to 2 plus root 3 plus 2 minus root 3 equal to 4. The special result provides a quick solution when we take out a and b as a factor from the first and the second denominator of the direct expression. E equal to 1 by a times 1 by a plus 1 by a plus 1 by b times 1 by b plus 1 by b. From the given expression we have already a equal to 1 by 2 plus root 3 equal to 2 minus root 3 and b equal to 1 by 2 minus root 3 equal to 2 plus root 3. So a plus 1 by a equal to b plus 1 by b equal to 4. Substituting this result in the direct expression, e equal to 1 by 4 times 1 by a plus 1 by b equal to 1 by 4 times 2 plus root 3 plus 2 minus root 3 equal to just 1. Answer is option A, 1. Easily solved in mind. Let's solve the next problem. Question 4 is, if x by xa plus yb plus zc equal to y by ya plus zb plus xc equal to z by za plus xb plus yc and x plus y plus z not equal to 0, then each ratio can be expressed as option A 1 by a plus b minus c, option B 1 by a plus b plus c, option C 1 by a minus b minus c, and option D 1 by a minus b plus c. The given expression forms a chain of 3 expressions and so it needs application of chained equation treatment technique. By this technique, an additional dummy constant is appended to the end of the chain, giving x by xa plus yb plus zc equal to y by ya plus zb plus xc equal to z by za plus xb plus yc equal to p. The advantage is, now we are able to form 3 independent equations with the dummy constant as x by xa plus yb plus zc equal to p or x equal to p times xa plus yb plus zc. Similarly, y by ya plus zb plus xc equal to p, or y equal to p times ya plus zb plus xc, and z by za plus xb plus yc equal to p, or z equal to p times za plus xb plus yc. The solution is just a step away now. Add up the three equations and you will get x plus y plus z equal to p times a plus b plus c multiplied by x plus y plus z. Or p equal to 1 by a plus b plus c, as x plus y plus z not equal to 0. Answer is option B, 1 by a plus b plus c. Again solve quickly in only a few steps. Last problem now. Question 5 is, if 3 times a square plus b square plus c square equal to a plus b plus c whole square, then the relation between a, b and c is option A equal to b equal to c, option B, a not equal to b equal to c, option C, a equal to b not equal to c, and option D, a not equal to b not equal to c. Expanding the RHS, we will get one number of a square plus b square plus c square, reducing three such factors in the LHS to 2. Let's show you the transformation by expanding a plus b plus c whole square. 3 times a square plus b square plus c square equal to a square plus b square plus c square plus 2 times ab plus bc plus ca. Or 2 times a square plus b square plus c square equal to 2 times ab plus bc plus ca. Now, it is a straightforward rearrangement of terms and application of the important algebraic concept of zero sum of square expressions. Collecting the like terms together, we have a square minus 2ab plus b square minus 2bc plus c square minus 2ca plus a square equal to 0. Or a minus b whole square plus b minus c whole square plus c minus a whole square equal to 0. With real a, b and c, for their sum to be 0, each of the square expressions must be 0. So, a minus b equal to b minus c equal to c minus a equal to 0. Or a equal to b equal to c. Answer is option A equal to b equal to c. You can solve this problem also easily in mind if you identify the concept and know how to apply the method. To read the detailed solutions, refer to the corresponding article in our website showsolve.com. The link is in the description of this video. And for latest updates, subscribe to our channel. Thanks for watching.